Now it's time to do our first transport technology, which is deploying MPLS Layer 3 VPN. And this is kind of a weird one for me because I personally feel very comfortable with MPLS Layer 3 VPN technologies. But at the time that I recorded this, I was starting to get worn down. And it's a really important thing to keep in mind your mental stamina when it comes to taking the CCIE exam. Because after a few hours, you kind of just start to wear down a little bit. And when something goes wrong, like it's about to happen to me, you may make the wrong choice. So I actually address this. At some point, you'll see pretty quickly that I get hit with a problem when I go to deploy a specific EIGRP configuration, and I choose to work around it in the wrong manner. So this is another one of those videos where I'm like, hang in there till the very end, because you're going to see me do something wrong, but later I'm going to call it out that was wrong, and this is why it didn't work or work the way that it did, and you're actually going to learn a lot about how BGP and EIGRP interact with each other. So again, I can't encourage you enough. Stick it out and watch it till the end, because there's going to be some very powerful knowledge coming at the very end of this. All right, let's get going. What's up, everybody? We are now moving on into our next task. This time, we're going to be tackling MPLS Layer 3 VPN between all of the customer sites and the customer edges. So we've got a lot of stuff that can happen here. Let me start by saying, if you're new to MPLS Layer 3 VPN, I watched Keith Barker's content to learn MPLS Layer 3 VPN. Specifically, I peer-reviewed his content in the NRC course on CBT Nuggets. And when I was looking at the blueprint for an RC, I pointed to MPLS Layer 3 VPN and said, I'll never be able to do that. And then I watched Keith's content, and I can do it from memory. It really is, let me mute this. It really is maybe the very best content I have ever seen on CBT Nuggets, or maybe even anywhere. MPLS Layer 3 VPN is a complicated thing, and somehow or other he broke it down step by step and made it easy. So this stuff that we're about to do takes that up a notch. This will be harder than what he deployed in his scenario, but what he deployed in his scenario is a very good start. So check out the CBT Nuggets content in the NRC course on MPLS Layer 3 VPN and learn how it works if you are new to it. If you're not new to it, let's jump into the tasks and get this going. So we're going to bring up the task here, MPLS Layer 3 VPN. Now there's 7 steps, but they're not easy steps because it's MPLS Layer 3 VPN. And pretty much all of it is going to take place on the MPLS core routers and then the customer edges. So here's what we're going to do. We're going to start by bringing them up in numerical order in secure CRT. I'm going to do the split screen yet again, just like we've been doing, and I'll kind of thumb it over a little bit so we can see all of the provider edges. I'm also going to shrink this down. A little shrunk too much, maybe. Okay, that's good enough. I think I can make this work. Yeah, okay. We're looking good at this point. And I'm not worried about the edge configurations that are going on to the SD-WAN topology yet. We're going to cover that when we get to SD-WAN. So I've got R1 pulled up. We'll do 2, 3, 4, 5, 6 is over here, customer 1, site 1. 7 is customer 2, site 1. 8 is customer 1, site 2. 9 is customer 2, site 2. 10, why did I do this? I don't know. Customer 1, site 4. 11, customer 2, site 4. 12, customer 1, site 3. And there's an update available for Photoshop. And because there we go. Okay, so there's all of them. So our first step, now that we've got all the terminals set up, configure IBGP on each router with AS Autonomous System number 6500. So this is within the MPLS network that we're focused on here. This is R1 through R5. R1 should leverage templates and reflect routes to each router. When I go back, I'm going to edit the task here to actually specify the router numbers to do this on. But recall that when we stood up the MPLS layer network, if I do show IP route, you can see we actually learned about all of the other routes via OSPF, including their loopbacks. So since this is IBGP relationships, I want to make these peers based on the loopback address. I want the neighborships to come up based on loopback addresses. Beyond that, notice the keywords they say here. It says leverage templates. This is not peer groups. This is templates. And reflect routes to each router. So this will not be a full mesh. R1 is dead center of this topology. So R1 is not only going to use templates, but it's also going to be a route reflector for all of the other items. So they're going to create each of the edge provider edge nodes here are going to create a neighbor adjacency to R1 who will then reflect all of the other items. So let's get it started. Router BGP 6500. I'll go ahead and say the router ID, BGP router ID. This is 1.1.1.1. And let's start with these templates. So this is going to be template, and we'll start with the peer session. So this is how we establish the session to the neighbors are going to be based off this template. I'm just going to call it session, something simple like that, and hit it into the session configuration mode. So what do we want to do here? We want to do update source and specify our loopback address. And the remote autonomous system for each of these neighbor adjacencies is going to be 6500. So that's just my session configuration. Now my policy is also going to be that all of these are going to be route reflector clients. So I'm going to specify template peer policy, and I'll call this policy. Go into this, and it's going to be route reflector client. Cool. So configuring these neighbor adjacencies. We configure the neighbor relationship in this router configuration mode. We configure the route reflector client adjacency in the address family itself. So let's bring up the neighbor adjacencies. I'm going to say we'll start with 2.2.2.2. And now we say we're going to inherit from our peer session, which was called session. And we'll go into address family IPv4, which by default is unicast, and I'm going to say neighbor 2.2.2.2 inherit peer policy, which we called policy. Okay, so let's bring up that neighbor relationship just to make sure our templates are working okay. I'm going to go to router 2, BGP 6500. Neighbor was going to be 1.1.1. Oh, that's terrible. 1.1.1. Remote autonomous system here. We don't have to use templates on R2. And update source loopback. Oh, it already came to life. Update source loopback. There we go. So that should be good to go there. If I go back to R1, we can validate here, do show BGP IPv4 unicast summary. We see that our neighbor relationship is up because the up status is ticking up. Of course, we're not advertising any prefixes. We're not receiving any prefixes at this time, so that's fine. Now let's configure the exact same items for the remaining neighbors in this topology. So now for the session configuration, I'm going to set this for 3333 and 4444. It reminds me of like a local lawyer here whose phone number is 4444444444. No, it's 4444444. I'm saying 4 too many times. And the commercial is just call 4444. Call 444-4444. And then it pans to somebody else who goes 444-4444. 444-4444. And it goes on and on and on. It's like the most obnoxious thing. Anyways, there you go. Learning about Louisiana stuff there, aren't you? Louisiana lawyers. Peer policy. Okay. Change this to 4444. 444-4444. 444-4444. Just once I want them to change it up and be like 444-4444. And he goes, no, 444-4443. Ah, threw you off. Anyways, okay. Sorry about that, people. So here what I can do is I can do show run section BGP. I'll copy the configuration from R2 and bring it up on R3. Enable config T. Boop. Enable config T. Boop. And enable config T. Boop. Okay. So at this point, the neighbor relationships should all be coming to life. There's 3, there's 4. Come on, 5. Give it to me. Show me the good stuff. Come on. There it goes. Now, thought I was going to have to go into debug mode there for a second. Okay, so we've got The neighbor adjacencies are now stood up. R1 is the route reflector, and we used templates, not peer groups, to make this happen because it explicitly called for templates. All right. Create VRFs for each customer, keeping in mind how routes will be transported over BGP. Okay, so when I create these VRFs, it's not just VRF name and address family. Because this is going to be carried over BGP, these routes are going to be brought into BGP through a VRF. These are going to be VPN v4 routes. So we have to have a route distinguisher and we have to have a route target. And we need to make sure that on each VRF, the route distinguisher and the route, the route targets need to be the same for each of these edge devices so that they can be imported. So R5, for instance, would import from R4, 2, and 3. So that does matter. So let's do this. We're going to do the VRFs are going to be on the edges. So let's go into R2 and be like VRF definition. We'll call this one customer 1. We're going to say route distinguisher is going to be 11. And we're going to activate address family IPv4. And our route target is going to be import 11 and export 11. Cool. So now if I do show run section VRF, I can, first of all, let's knock out customer 1 on routers 3 and paste, routers 4 and paste, and routers 5 and paste. Okay, now let's do customer 2. So exit here. We're going to say, get out of this VRF mode here, VRF definition, customer 2. Route distinguisher is going to be 22. And address family is going to be IPv4, unicast. And route target, import to 2, export to 2. Do show run section VRF. Nope, not VRD, VRF. Okay, now I'm going to grab customer 2's info. And just, cleanliness, right? I know it'll work. I just, hey, just let me do my thing, all right? Exit, paste, good. Okay, cool. All right, VRFs are done for each customer. They're able to be distinguished from one another. We also have the import and export for VPN4 now configured. Configure EIGRP relationships between customer 2 and the MPLS provider edges, keeping customer 2's traffic segmented from other customers' routes. Okay, so customer 2 is my green sites. So we're going to do EIGRP on the green sites on the WAN interfaces, and also EIGRP within the corrective customer 2 VRF on the provider edges. So let's actually start with the provider edges since that's what we've been working with. And let me get a lay of the land with my interfaces. So here I'm looking at router 2. And on my diagram, in fact, looking at my diagram, all of my connections to my customer 2 sites are on E02 on all of my provider edges. So that simplifies this for me in the sense that we're only going to be working with E02. Looking at this too, look at this. Okay, yeah, this is right. This is good. Okay, yeah, I almost got confused. Okay, so let's do this. We need to bring up router EIGRP. I'm going to do this in named configuration mode. Address family is going to be IPv4, but for VRF, customer 2. What am I forgetting? Oh, the autonomous system number. Okay, we got to give it an autonomous system number. So let's do for VRF, for customer 2, we're going to do autonomous system 222. For customer 1, we're going to do autonomous system 111. So let's do autonomous system 222. And we're going to do our network statement on Ethernet 02, 192.169.29. Yeah, because I can see here this connects router 2 to router 9. .0, 123.255. Okay, now let's also make sure we set that VRF on Ethernet 02. Oh no, this is going to wipe out my IP address, isn't it? VRF definition, VRF forwarding, customer 2. Yep, sure did. IP address. Let's grab that IP address real quick. And that's 255.255.255.0. So now if I do show IP interface brief, still have the IP address, do show IP route, VRF customer 2. I see my route there. Do show, no, not do, show IP EIGRP. Do I specify VRF right here? VRF customer 2 interfaces. Yeah, cool. So I now see that my interface is participating in AS222 and the customer 2 VRF. Let's bring up the neighbor adjacency to R9, which already has EIGRP running on it. See, do show run section EIGRP. That's what we configured in the last video. So I see that EIGRP is already running on autonomous system 50 there. So we're going to specify a new address family with a new autonomous system and specify our WAN interface. So config T, router EIGRP, CCIE, address family IPv4 unicast autonomous system 222. Oh, that hurts. So we need to configure a VRF here. You absolutely do not need to configure a VRF here. I don't know, I guess I was just exhausted at this point and was not thinking about the right solution. The obvious right solution is just to create a second EIGRP instance. I could have done router EIGRP CCIE2 and then created a new autonomous system within that and then redistributed between them. But for whatever reason, my mind thought that I could only have one EIGRP instance right now, and I knew that you could have multiple, but for whatever reason, I wasn't thinking about that clearly in this context, and I fight through the rest of this video pretty much trying to get these two VRFs to exchange routes between each other. And I eventually get it working, and you're going to learn a lot about how BGP operates between EIGRP, especially over an MPLS Layer 3 VPN. So stick with it. Towards the end, you'll see it work, and you'll see this actually does teach some pretty cool things, but know that the correct solution was actually just create a second EIGRP instance and redistribute between those two EIGRP instances. Is that what we're doing? I think that's what we're going to end up doing. It's configuring a VRF here. And then we're going to have to route leak. Ugh, this is a mess, isn't it? I think that's what we're going to have to do. That's a pain. But, c'est la vie. That's life, isn't it? Okay. So be it. Let's make a definition. VRF definition, I'm just going to call it WAN. Address family IPv4, unicast. Let's exit. Exit interface Ethernet 00. Do show IP interface brief. VRF forwarding WAN IP address. This was my IP address in the WAN side. Okay, and now let's go back into router EIGRP CCIE address family IPv4. VRF, WAN, autonomous system 222. Network 192.169.29.0.123.255. Man, why'd I make this so hard on myself? Okay. And so what I'm going to have to do is leak all of those EIGRP learned routes distribute. And I can do that by leaking my VRF global, which was EIGRP. Autonomous system, what was our autonomous system? 50? This might work. Okay, this might work. Okay, that's what we're going to try and do. Maybe I should have tested this stuff before I actually went through it. All right, so I got the neighbor adjacency brought up on R9. Let's do the same thing on R7. Oh man, I really hope I can figure this out. Router EIGRP, CC. Nope, we got to make the VRF, don't we? VRF definition. WAN, address family IPv4 unicast. Do show IP interface brief. Interface Ethernet 00. VRF forwarding WAN. IP address was this guy here. 255.255.255.0. Let's do router EIGRP CCIE, address family, IPv4, VRF, customer, note WAN, autonomous system, 222, network 192.169.47.0, 123.255. Let's bring it up on R4. So exit, interface Ethernet 02. VRF forwarding, customer, nope, do show IP interface brief. VRF forwarding, customer 2. IP address was on Ethernet 02. Ugh, mess. 255.255.255.0. Router EIGRP, CCIE. Address family, IPv4, VRF, customer 2, autonomous system 222, network 192.169.47.0, 123.255. Adjacency is brought to life. Let's do router 3 to router 11. So let's do interface Ethernet 02. Almost did it again. Do show IP interface brief, VRF forwarding, customer 2. Oh man, I made this way too hard on myself. 192.169. This is on Ethernet 02, 113.0, 123.255. Nope. I'm getting ahead of myself. 255.255.255.0. Bad mask. 3. Okay. Router EIGRP, CCIE. Address family IPv4, VRF, customer 2, autonomous system 222, network 192.169.113.0, 123.255. Adjacency come to life. Oh, we have to make the adjacency come to life on R11 side, don't we? Okay, config T, VRF definition WAN. Address family IPv4 unicast. I'm not doing any route distinguisher or route tagging in this case because we're not transporting this over BGP or VPN v4. I'm just creating the VRF in this case so that I can make this somehow work with an EIGRP. Blah, blah. Ew. Okay. So messy. Why did I do this to myself? Why did I do this to you? You're just sitting here trying to learn. Knox comes along and makes the worst damn test ever. Okay, VRS. Oh, what have I done? IP address. I finally did it. 192.169.113.11. I'm pretty sure was the address. We're about to find out, aren't we? EIGRP, CCIE, address family, IPv4, unicast. Nope. VRF. WAN. Autonomous system 222. Network. 192.169.113.0, 123.255. Please come up. Yes. Okay, lastly, we're doing router 5 to router 13. So let's do router 5 here. Enable show IP interface brief, not making that mistake again. Config T, interface Ethernet 02, VRF forwarding, customer 2. IP address 192.169.135.5, 255.255.255.0. Router EIGRP, CCIE, address family IPv4, VRF, customer 2. Autonomous system 222. Network 169.135.0.123.255. Nope. Lastly, router 13. Config T. VRF definition WAN. Address family IPv4 unicast. Exit. Do show IP interface brief. Now for real exit. Still for real exit. Interface Ethernet 00. VRF forwarding WAN. IP address 192.169.135.0.123.2. Nope. Still on that wildcard mask. 255.255.255.0, and gotta fix this. Okay. Oh no, duplicate address. Yep. Definitely a duplicate address. Okay. Router, EIGRP, CCIE, address family, IPv4, VRF, WAN, autonomous system 222. Network 192.169.135.0.123.255. Please come to life. Okay, cool. So all the neighbor adjacencies are now brought up with customer 2. They're within their respective VRFs. Now configure EIGRP relationships between customer 1 and the MPLS provider edges, similarly keeping them within the VRF. Luckily, customer 1 used OSPF, so we won't have to do any nasty route leaking within the VRFs themselves. Okay, so let's jump over to router 6 and bring it to life with router 4. I know there's a whole lot of repetition here, folks. I know. It's kind of dry sometimes. At least in this case, we're not doing any VRFs. So I can just do router EIGRP, CCIE, address family IPv4 unicast, autonomous system. We said this was going to be 111. And in this case, I'll say network 192.168.6. Right? No. 9. 46. 0.123.255. Over here on router 4. Now backing out of the address family configuration. Now we're saying address family IPv4 VRF customer 1. We'll have to assign that VRF to the interface after the fact, but we'll get this brought up. 192.169.46.0.123.255. Now let's bring up that interface real quick. That's going to be interface Ethernet 01, VRF forwarding, customer 1, IP address 192.169.46.4.255.255.255.0. That should bring up the dual adjacency. There it is. Okay, so that's done. Let's do router 8 to router 2. So IP interface brief, config T, interface Ethernet. This is again going to be 01, VRF forwarding, customer 1, IP address 192.169.28.2.255.255.255.0. Exit router EIGRP CCIE address family IPv4 VRF customer 1. Autonomous system 111. Network 192.169.28.0.123.255. Please come up. Please come up. Why didn't you come up? Why didn't you come to life? Router 8. This was router 8, right? Did I just do that on the wrong router? Did I really just do that on the wrong router? Or did I not do it at all on router 8? Show run section EIGRP. I have not done it at all on router 8. Okay. There's so many things that can repeat. Autonomous system 111. Network 192.169.28.0.123.255. There we go. Okay. So at this point, let's take a look at router 2. Show IP EIGRP. Nope. Show IP EIGRP. Come on. VRF customer 1 neighbors. There we go. and customer 2 neighbors. There we go. So I see my neighbor relationships segmented for each neighbor. That's great stuff. Let's go to router 3 and bring up router 10. Exit, interface Ethernet 01. Yeah. We are forwarding customer 1, IP address 192.169.103.255.255.255.0. Exit router EIGRP CCIE address family IPv4 VRF customer 1 autonomous system 111 network 192.169.103.0.123.255. Now let's jump over to router 10. Config T router EIGRP CCIE address family IPv4 unicast autonomous system 111 network 192.169.103.0.123.255. Come on. Yeah. Okay. So router 3 is all set, router 4 is all set, router 2 is all set. All we have left is one last adjacency between router 5 and router 13. Let's make it happen, Captain. Interface Ethernet 02, VRF forwarding, customer 1, IP address 192.169. No, this was Ethernet 1. Man. What have I done? That was my best Hayden Christensen impersonation in Star Wars Revenge of the Sith. What have I done? I hope you enjoyed this. Please feel free to nominate me for an EGOT for my hard work. I practice that every morning in the mirror. Okay, router EIGRP CCIE address family IPv4 VRF customer 1 autonomous system 111 network 192.169.125.0.123.255. Jump over to router 12. Bring it to life. Config T router EIGRP CCIE address family IPv4 unicast autonomous system 111 network 192.169. What did I say? 105? 125. Cool. Neighbor adjacencies are all brought to life. Okay, so that's 1, 2, 3, and 4 done. Step 5, configure R1 to properly forward VPN v4 to other neighbors. Okay, so that makes sense. These are going to be sending in VPN v4 routes now because they're route distinguished and route tagged. Their neighbor adjacency is only to R1. So R1 is going to have to act as a route reflector for VPN v4 information too in the VPN v4 address family. Similarly, looking ahead to step 6 right now, configure R2 to R5 to send VPN v4 routes. That means, it's not just enough to set it up as a VPN v4 route. We have to activate the address family on all routers destined to their neighbor. So let's start with R1 though. This is config T router BGP 65000. Address family is now VPN v4. That's all we need. FlowSpec, that CenturyLink outage that just happened, y'all, man, that's crazy stuff. I learned a lot about FlowSpec because of that. So, kudos to all the parties who, kind of disclosed what happened and made it a learning experience to everyone. That was actually pretty cool. All right, VPN v4, we're going to say our neighbor is 2222, route reflector client. Have to activate it first. Activate. Now I can do route reflector client and neighbor 2222 send community both bot both. We have to send all the community strings so that it has that. Let's do the same things for 3333. Let's do send community to 3333. And set 333 to be a route reflector client. Let's do 4444. 444, 4444. 444 4444. Gets me every time. Every single time. And we're doing 5. Activate it first. Yeah. Activate. Send community both. And route reflector clamp. Okay, now we need to do the same thing for R2. Router BGP 65,000. Of course, this will only be destined for R1. So address family VPN v4. Neighbor 1.1.1.1. The cool thing about this is I can also copy and paste all these commands. So activate and send community both. Okay, so here's what I'm going to do. Where's my handy dandy notepad? Bring up a notepad. Let's copy these commands. Paste. Address family VPN v4. Paste. Neighbor 1. Activate. And neighbor 1 send community both. Activate. Copy and paste. Exit. Exit. Cool. Exit. Cool. And exit. Exit. Cool. So that should tackle 6. Now we've got the final step, which is perform all the correct route redistributions. Okay, so time to start the redistributions. So the way this is going to work is we're going to be redistributing from the EIGRP process, into the BGP VRF process, which is then going to be carried via a VPN v4 route. So let's start with like router 2. This is where our first redistribution is going to take place. I'm going to say address family IPv4 VRF customer 1. Then I'm going to say redistribute EIGRP. And then the autonomous system here for customer 1 was 111. Let's now jump into customer 2. Redistribute, actually just hit up. And set this to 222 was the autonomous system for EIGRP 222. Now let's do the same thing for router 3. Address family IPv4 VRF customer 1. Redistribute the EIGRP process running in that VRF, which was 111. Change the VRF to customer 2. Redistribute 222. Same thing with router 4. Address family IPv. I'm kind of nervous about this, you guys. Like, I've done this a few times. I've done MPLS Layer 3 VPN a few times, but every time it's like, man, is this really going to work? Customer 1, redistribute EIGRP 111. Customer 2, redistribute 222. Exit. Address family IPv4 VRF customer 1, redistribute EIGRP 111, customer 2, redistribute 222. Okay, so look at that. There's the routes carried via BGP. Okay, so now we need to redistribute my BGP routes into that EIGRP VRF. That way, these routes will show up on my remote routers. We are so close to getting this done, you guys. This is so cool. Router BGP 60. No. EIGRP CCIE. Let's do address family IPv4 VRF customer 1. Autonomous system 111. Redistribute topology base. Redistribute BGP 65,000. Exit. Exit. Let's grab our next customer 2, autonomous system 222. Topology base. Redistribute EIGR BGP 65,000. Proud of us. Proud of us. Yep, sure am. Okay. let's do this. There's a lot of commands I don't want to have to type over and over and over again. Sorry for being a lazy bum. Topology base. Ah, blah, ah, ah. A couple exits. Oh no! Topology base. Top base. Top base. Top base. Top base. Redistribute. Okay. Let's grab these. 3. Just exit out all that stuff. Okay. 4. Exit out all that stuff. Boop. 5. All right, so now looking at customer 1, R8. What we got going on here, R8? Show IP route. Hey, yo, that's looking good. So I've got my EIGRP learned routes over the MPLS Layer 3 VPN. Ping 192.169.46.6. Ha! It's a beautiful thing, guys. I absolutely love it. So, it does say perform the correct redistribution, right? So we got to bring this into my LAN segment. Redistribute EIGRP, autonomous system 111, subnets. Let's just give it a metric of 10, something like that. Metric type 1, why not? You know, it doesn't say anything. Just make it there. If that worked, I can slide this over. We should look at R15. And I see my external routes. Similarly, from R8, I could now go into router EIGRP 111. Router EIGRP CCIE, address family IPv4 unicast, autonomous system 111, topology base, redistribute, OSPF 1. Oh no, with a metric. A million or something. Reliability, no delay. 10, how about that? That's fine. Reliability, 255, 1, 1500. There we go. So, now when I look on router 6, yeah. Oh man, it's a beautiful thing. It really is a beautiful thing. See that? That's R15 up here. That's R15's loopback. There it is. Working like a dang charm. All right, perform the correct distribution. I know I'm avoiding that VRF route leak, you guys. Router, OSPF 1, redistribute, EIGRP 111, subnets, metric 10, metric type 1. Exit router EIGRP, CCIE. Address family IPv4 unicast, autonomous system 111, topology base, redistribute, OSPF 1, metric, bajillion, delay of 10, reliability of 255, load of 1, MTU of 1500. That's right, I memorized my K values in the redistribute statement. Let's slide it back over. We'll redistribute at 10. That way this will be carried through that entire huge stinking backbone. If I look at 10 though, show IP route. Oh, those beautiful routes. Man, I love this. Love MPLS Layer 3 VPN. Router OSPF 1, redistribute. EIGRP 111, subnets, metric 10, metric type 1, exit. Exit? Too far. Router EIGRP CCIE. Address family IPv4 unicast autonomous system 111. Topology base. Redistribute. EIGRP. Nope. OSPF 1. Metric. Gajillion. Delay of 10. Reliability 255. Load of 1. MTU 1500. What does R43 think about this, for instance? Thinks it's got a lot of routes. Blah! It's so cool. And it makes me so happy. Oh, man. Makes me happy. Of course, this is NSSA over here. So it's not sending any Type 5 LSAs in at that point. We got a summary address coming in, so it'll have a default route on the other side of router 43. We could do it on our R12, but because it's already connected through the backbone, it's already got the routes. It's all there. But we could have 2 redistribution points, do some route tagging. It doesn't say to do that, so not too worried about it. We got to face our fears. Router 13, customer 2, site 3. Here it comes. Show IP route. It's not going to be in there because that's the global routing table. Show IP route VRF WAN. Okay, so it's got those routes. Router EIGRP CCIE. Address family IPv4 unicast. What is my autonomous system here? Do show run section EIGRP 20. Okay, address family IPv4 unicast autonomous system 20. Topology base. Redistribute VRF WAN. EIGRP. Autonomous system number was 222. I don't really need to specify a metric because it's redistributing from EIGRP to EIGRP, so the metrics carry over when you redistribute from one EIGRP process to another. So this is redistributing from the WAN VRF into the global routing table. Then I'll have to do it in the reverse direction. So let's do that. Address family IPv4 VRF WAN, autonomous system 222. Topology base, redistribute VRF global. What do I want to redistribute? EIGRP, autonomous system. I already forgot my 20. Can I redistribute anything else? No. Well, I guess do show IP route VRF WAN. I don't see anything there. I know sometimes this VRF route leaking can take a little bit. Can I do show IP route? So I'm not seeing anything bouncing here. Do clear IP EIGRP. Clear IP route. Let's clear IP route. Topology. Nope. Clear IP route all. How about that? Clear IP route VRF WAN all. Bounce them all. Show IP route. Still nothing there. And show IP route VRF WAN. Still nothing there. Okay. Let's also try I want to try this just for fun to see if this works. I drew a router EIGRP CCIE. Address family IPv4 unicast autonomous system 20. I'm going to try and redistribute my connected routes and see if that still takes effect. Redistribute VRF WAN connected. Metric 1, 2, 3. Oh, you know what? Maybe I do need to specify a metric. Okay. Okay. 2551 1500. Nope, still not seeing anything coming in from that VRF. I know that sometimes route leaks themselves take a while to sync. And if I do the same thing in the reverse direction, exit, exit, address family, IPv4, VRF, WAN, autonomous system, 222. No, I did say 222, right? Oh, where did I do it? Man, way up here. Ah. Okay. Okay. Distribute VRF global connected metric bandwidth. Then delay, reliability, load, MTU. Do show IP route VRF WAN. Still nothing. Do show IP route. Still nothing. No love here. All right, so what I'm going to have to do, I'm going to pause and research this because I don't know why the redistribution from one VRF to another isn't working even when we specify the metrics. That should definitely work, I think. Yep. So I'm going to pause it. I'm going to find the answer to this. I'm going to come back. Okay, so thanks to a forum post, I found the solution, and it's not terribly unlike what we've been doing. You have to redistribute the routes into BGP, into the VPN v4 section, and then from there you can pull them out and do it that way. So let's make that happen. So really, to do this, both sides have to be in a VRF, don't they? Yeah, they do. So that way they could be distinguished and then pulled out of each other. So let's try and make this happen. I mean, I just barely skimmed that article. Now I'm just kind of thinking through how it would work. So if I do show IP interface brief, my inside interfaces now, my LAN 2 here on router 13, that's going to have to be in a VRF. So I've got my WAN VRF. So if I go into VRF definition WAN, we first need to set a route distinguisher. Let's just say 1.1, and address family IPv4 unicast. Yeah, and then we'll say route target import 1.1 route target export. Is that what we want to do? I don't think that's what we want to do. Maybe that's what we want to do. Let's do that. Exit, exit, VRF definition, LAN now. We'll call this route distinguisher 2.2. Address family, IPv4 unicast, route target, import 2.2, route target export 2.2. Because we're not doing the leak in BGP, that's where you could do route targets to leak routes. So I could export one route here and import it in a different VRF. We could also just make an import statement that pulls it out of the global routing table, but I don't think we need to do that. We do, however, have to now go to Internet Ethernet interface Ethernet 0.2. This is actually going to wipe out a lot of my EIGRP configuration. Let's do show run section EIGRP as well. Okay. So we're going to do Ethernet 0.2, which is this IP address. So interface Ethernet 0.2, VRF forwarding, LAN, IP address. Here we go. 255.255.255.0. Now I need to exit out of this. Router, EIGRP, CCIE. No address family IPv4 unicast autonomous system 20. Address family IPv4 VRF LAN autonomous system 20. Network 10.0.23.0.123.255. Network. Bring up my loopback one more time. Okay. Okay, so now I'm going to do router BGP. Let's do like 65,003. How about that? I'm going to say, what am I going to say? Address family, IPv4, VRF, WAN, redistribute EIGRP. This is 222. Exit, address family, IPv4, VRF, LAN, redistribute EIGRP 20, right? That's what we said? Yep. Okay. So now what I'm going to do is go into router EIGRP CCIE, address family IPv4 VRF LAN, autonomous system 20, topology base, redistribute BGP. This was 65,003 metric. This would be cool if this works. So now if I do show IP route VRF LAN, nada. That did not work. Okay, time to research some more. Why didn't that work? Okay, so my initial hunch with configuring the VRFs was wrong. You do have to export out of one VRF and into another VRF. So if I do show run section VRF, let's see. Yeah, this is a little art. This is a great little forum post someone had on this. I've never actually done EIGRP to EIGRP redistribution between VRFs, so this is kind of a first one for me. And you're watching me learn right now. So there you go. So let's exit all the way out of this. VRF definition. Oh, still going. VRF definition LAN, and let's do address family IPv4 unicast, address family IPv4. Let's say no route target import 22. Now let's say route target import 11. Let's exit out of this and say VRF definition WAN, address family IPv4, no route target import 11. Here, let's just copy that. How about that? Let's say route target import to 2. So now look at this. Do show run section VRF. See this? This one, the LAN side is going to be exporting 2.2, and the WAN side is going to be importing 2.2. And the flip side of that is true for exporting 1.1 and then importing 1.1 over here. So now let's take a look at my BGP configuration. Section BGP. So I've got my redistribution taking place within the VRF. So that should be good based on the VPN v4 configuration. And now if I do show run section EIGRP, we need to fix the WAN side. So let's do router EIGRP CCIE, address family IPv4, well I guess you can't say unicast, VRF, WAN AS 222, topology base. Let's do no, and then delete out this redistribute command. Boop. Redistribute BGP 65,003 metric. Bajunch. Okay. So lots happening here. Show IP route VRF WAN. Oh, look at that. That's it. That's it. There it is. There's those BGP routes now showing up in my VRF. Show IP route VRF LAN. And there's my WAN side interface right there. Oh, really cool. That's really cool. I really like that. Okay. Fun. So that takes care of almost R19. Now we need to redistribute those BGP routes into, right? No. Let's see. Show. So the reason why the BGP routes are not showing up as dual external is autonomous system, or is administrative distance. We have an AD of 20. But if I do show IP, EIGRP, VRF, WAN topology, I see the routes. So they are brought in to the topology table, which is pretty cool. So now the question is do we need to redo this on show IP route VRF WAN? There they are. Look at that. Now their external routes showing up here on a different router across the way on R11. So now we need to recreate this on R11, 7, and 9. But at least we know what we're doing this time now, right? So, so let's do 11 just to get on this side. Okay. Config T. Let's start by setting the VRF definition for WAN. Route distinguisher, we're going to say 1.1, address family IPv4, and we're going to say route target. Let's say import 1.1, route target export 2.2. Let's exit out of this. VRF definition LAN, RD22, address family IPv4, route target import 2.2, route target export 1.1. Cool. Let's fix E03 and E02 to show run section EIGRP. Cool. Exit router EIGRP CCIE. No. Address family. Oh. Looks like I've already got router EIGRP 60. EIGRP 60. Look at this. I set myself up for some fun stuff here. Upgrade. Is it EIGRP upgrade? Yeah. Upgrade CLI. And we're going to set this into the name CCIE. Man. How about CCIE leak? Something like that. 60 upgrade, EIGRP upgrade CLI to CCIE leak. Yep. Okay, so now if I do show run, actually I just need to delete that out. This needs to be in the same EIGRP process, doesn't it? Okay, no router EIGRP CCIE leak. How about that? Just delete it out. Router EIGRP CCIE. Nope, we need to set our interface. We need to actually set these in the VRF first. Do show IP interface brief. So let's set the LAN side interfaces in the VRFs. Interface Ethernet 02, VRF forwarding, LAN. IP address was this. 255.255.255.0. Interface Ethernet 3, VRF forwarding. And this was 244.11. Okay. Router EIGRP, CCIE. Address family IPv4, VRF LAN. Autonomous system was something, 60. Network statement 10.0.24.0.123.255. Network 10.0.244.0.123.255. Okay, let's bring them into BGP. Right, router, BGP, let's call this 65,000, I don't know, 10, something like that. Address family IPv4 VRF WAN, redistribute EIGRP 222. Let's go to the LAN VRF, redistribute EIGRP 60 was what it was, right? Yep. So now those are brought into VP and v4 configurations. Now we should be able to go back to the router EIGRP CCIE address family IPv4 VRF WAN autonomous system 222, topology base, redistribute BGP, what did we say, that's 65,010, metric, gajillion, delay, reliability, load, MTU. Change the VRF to LAN, autonomous system 60, topology base, redistribute BGP 65,010, metric, gajillion, 10, 255, 1, 1500, and show IP route, VRF, LAN. Looking great. LAN, and there they are. Yes, 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 yes. Man, this stuff makes me happy. Cool. Jump on over to the other side. We got R7 and R9 left to do. You know what? I bet I could just do a lot of copy and paste here instead of retyping all that. Show run. All right, let's do this. VRF dev, let's just copy it like this. So let's go to R7, enable, config T, whoop, okay. All right, let's see what else we could copy and paste. Scroll on down some more. All right, we got to set all of these interfaces in my VRFs. So 2, 3, and 1, 0. Interface brief. Okay, interface Ethernet ZE02. VRF forwarding LAN. IP address 10.0.21.07. 255.255.255.0. Interface Ethernet 03. VRF forwarding LAN. IP address 10.0.57.7. 255.255.255.0. Interface Ethernet 10. VRF forwarding LAN. IP address 10.0.99.7. 255.255.255.0. Do show run section EIGRP. Router EIGRP CCIE. No address family IPv4 unicast autonomous system 50. And keep in mind we have like variants and traffic share set up there, so we need to fix all of those. Let's do address family IPv4 VRF LAN autonomous system 50. Let's grab all of these statements. Cool. Adjacencies come right back up. Very good. Very, very good. Okay, so now we need to do the BGP. Router BGP, let's do 65,011. How about that? Address family IPv4 VRF LAN. Redistribute EIGRP 222. Address family IPv4. Let's exit out of that just to make it nice clean. Address family IPv4 VRF LAN. Redistribute EIGRP 50. And now we can go back into router EIGRP CCIE and perform the redistribution there. Address family IPv4 unicast. Autonomous, no. VRF LAN. Autonomous system 50. Topology base. Redistribute BGP 65,011. Metric bajillion. Delay 10. Reliability 255. Load 1500 MTU. Let's set the LAN VRF autonomous system 222. Topology base. Top base. Redistribute BGP. Okay. Do show IP route VRF WAN. Boop. Everything looking good. Do show IP route VRF LAN. Boop. So much good looking stuff. That's cool. That's really neat. That's really, really neat. Oh, I wonder why they say they're possibly down. I wonder what that's all about. We'll have to investigate that later. Let's finish this up with R9. What was I doing? Okay. Show run. Let's grab these VRF definitions. Let's try that again because I got a syslog message in there. Show run. VRF definitions. Nope. No, what have I done? No IP domain lookup. Waiting again. Painful. Painful. Painful, I tell you. Okay, just waiting for... This is why no IP domain lookup. Why did I not set no IP domain lookup on all of these devices? T, router E... Nope. VRFs. Okay. Let's say back to R7. Actually, you know what? From here on out, we can do these things. Do show IP interface brief. Setting the LAN side interface of E02. VRF forwarding LAN. IP address 10.0.22.9.9. 255.255.255.0. Exit. Do show run section EIGRP. Router EIGRP CCIE. No address family IPv4 unicast autonomous system 50. Address family IPv4 VRF LAN autonomous system 50. Let's grab this. There. Okay. And now let's bring BGP to life. BGP, let's do 65,012. How about that? Address family IPv4 VRF WAN. Redistribute EIGRP 222. Address family IPv4 VRF LAN. Redistribute EIGRP 50. Now let's go back to the EIGRP config and bring this thing home. EIGRP CCIE. Address family IPv4 VRF LAN. LAN autonomous system 50. Topology base, redistribute, BGP 65,012, metric, bajillion, little delay, perfect reliability, tiny load, 1500 MTU. Let's grab WAN, autonomous system 222, topology base, and the redistribution command. There we go. Okay, that should do the trick. RF WAN, see all those routes looking good. Wow, that's a whole lot of stuff. Show IP route VRF LAN. Very cool stuff, guys. Very cool stuff. Okay, so yeah, that's pretty cool. I think that does the trick here. Kudos to us for making all that happen. And that finishes the MPLS Layer 3 VPN section. Really nothing bad here until we got into like redistributing between VRFs and EIGRP. And there's some tomfoolery going on here where I see like some external routes are showing down. I'm not really sure what that's all about. And I'll have to dig into why that may be the case. But I'll say that wraps up our lab task here for MPLS Layer 3 VPN. So for the rest of the way here, we've got multicast, DMVPN, SD-WAN, automation, and SD access. This really did tackle the core of the routing, switching, and services portions of the exam. So if any of this is a little fuzzy, like it was for me, brush up on some topics and go check out CBT Nuggets content too. So thanks for stopping by, y'all. I'll see you in the next one. So I want to take a moment to record a message about what you just watched me go through, because this is an important talking point. We got to this point on our Customer 2 sites where we had to create an EIGRP instance on the WAN side and an EIGRP instance on the LAN side. And let's recap what really happened here. If I go into configuration mode, I'll just say router EIGRP CCIE. Let's say we had created our first EIGRP instance of like 66. Make something up. Address family, IPv4 unicast, autonomous system 66. So then it's like, okay, we had that maybe on the LAN side. Now it's time to create one on the WAN side, and we set it to 77. And it gives us this error. Changing from AS66 to 77 is not allowed. And that blew my brain up for a second. And it made me think, okay, well, since I can't have two autonomous systems in the same EIGRP instance, I have to do it in VRFs, right? And that's not correct. The VRF thing is a solution, and it does work, but the right solution was actually just create a new EIGRP instance and set address family IPv4 unicast autonomous system 77 there. And then redistribute between those EIGRP instances. That would have been the cleanest way to do it. That way you don't have to bring VRFs into the picture, and you don't have to bring BGP into the picture. That being said, let me delete this out real quick. We're going to do, just to clean up my config, that way I don't run into this later, we're going to do no router EIGRP CCIE2, and let's go into router EIGRP CCIE, and let's delete this address family that I just created real quick. This is just to clean up my mess. Let me show you some things that you may have noticed in the previous video. So on router 9, if I give this a show IP route VRF WAN, you see this? We've got all of these routes that are possibly down. And this has to do, these are all externally learned routes because this is what's coming in over the MPLS VPN. And as they come in over the MPLS VPN, the provider edge is redistributing out of BGP into EIGRP, and EIGRP learns these routes quickly. BGP doesn't always move as fast. And the result of when these external routes are down is if you go to show BGP VPN v4 unicast all to look at the table, look at this. None of those external routes are here. And that's because they're possibly down. See, if I do show IP EIGRP VRF WAN topology, you can look at the topology table, and it tells you now that these items do actually exist in the topology table. It does have a feasible success or a successor with the reported distance. Now, if I do show IP route VRF WAN, are they still down? They're definitely still down. So something is happening as routes come out of BGP into EIGRP and then into the routing table. And this all has to do with the timing of how BGP communicates to EIGRP, which communicates to the routing table. And these two protocols have differing opinions about the routes, and they're competing to get into the route table. So ultimately, if you do show IP VRF route, VRF LAN, and you look at the other route table, like there's basically nothing in there. The redistribution doesn't take place, and these routes are all possibly down, and it's just a hairy mess. So ultimately, what needs to happen here is you just have to wait, and then you have to do clear IP route VRF WAN star. You just have to clear these routes, watch the route tables bounce, and wait for these prefixes to come in, or you just need to create the EIGRP neighborships correctly without having to do VRFs and BGP. So, you're kind of playing a waiting game here, but now these routes are showing up. So if I do show IP route VRF WAN, look at that. See? Now they're all there, and they're not showing as possibly down. The issue there was that routes that came out of BGP, let's do it. Show IP BGP, is it VRF WAN? Yeah. Let's do, maybe not. Show BGP, hang on. I'm going to get there. Just bear with me. Is it IP? Man, I just did this. There's a command. Actually, it's show. It's in the EIGRP table. Again, my brain is fried. VRF WAN. Let's look at a specific route in the topology table that's now external, like 10.0.23. So 10.0.23.0. Does it need CIDR notation? No, it needs this. It needs full prefix mask. Okay, so now we actually see all of this historical information regarding that specific prefix. We see what it came in via BGP. BGP has the ability to actually carry the EIGRP information with it as part of the community, which is pretty cool. Show BGP VRF WAN. Yeah, man, I really thought there was a way that I could look at the specific prefix that's advertised. It might be show VRF WAN VPN v4 unicast and then the specific prefix. Yeah, okay. 10.0. So if we do show BGP VRF WAN VPN v4 unicast and then, oh man, this is a mess. 23.0/24. There's the command. Look at this. See these extended communities for the route target 1.1? Those extended communities, each one of these right here, the 08801, this is the autonomous system, and then something else. 8802, this is going to be like the delay and the bandwidth. 8803 is the MTU. 8804 is the remote BGP autonomous system, followed by metric information. Do you get the idea what I'm saying here? Is all of that EIGRP information is carried across BGP's VPN v4 here. And this is what's important to have. You have to have this information to know if it's reachable via what autonomous system. The really cool thing about this specific extended community that's being brought is this. If you have two EIGRP autonomous systems on opposite ends of an MPLS Layer 3 VPN, so I've got across, well, like at Site 3, I've got EIGRP Autonomous System 10, and at Site 4, I've got EIGRP Autonomous System Site 10. Because these extended communities send all of the attributes across BGP, they can show up as within the same autonomous system, like basically like an intra-area route in OSPF. So you don't have to have different autonomous systems across an MPLS Layer 3 VPN because the communities with VPN v4 can send it. So that's what I wanted to record. I wanted to let you know that if you're following along and it's like, wait, why isn't this working? Why are my external routes not coming in? Why does everything show down? You got to wait for BGP to propagate all of that community information, then clear the route table so that it loads up again correctly. So that's what I wanted to record regarding MPLS Layer 3 VPN. Also keep in mind the cleaner solution is just create a new EIGRP process and redistribute between those instead of creating VRFs and BGP instances. All right, for real, thanks for stopping by, y'all. See you in the next one.